most popular AI assistants like ChatGPT or Google Gemini can be a privacy nightmare. Are you sure you want to provide potential personal information to these companies to further train their language models? A solution to this problem is to run these large language models locally on your machine. But what if you just have a Raspberry Pi lying around? Could you run something like ChatGPT or DeepSeek R1 on it? Let's be real, probably not, but let's see how close we can get. Here is my experience trying to run an AI assistant on my spare Raspberry Pi. Let's get to it. The first question we have to think about is whether it's even possible to run an LLM on a Raspberry Pi. Usually, when you look into these language models, you hear about how much GPU power they require to work. Raspberry Pis have an integrated GPU, kind of, but it's not really suitable for this kind of work. So we are going to have to go the full CPU route on this endeavor. It makes the token generation slower, but it's pretty much the only way we can get it running at all. The next issue we run into is the RAM. These large language models devour tons and tons of RAM or VRAM for loading the model's weights. An extreme example is DeepSeek R1, which, at close to full precision, can require almost a terabyte of RAM. Luckily, in this space, there is nowadays tons of competition, with models ranging from tiny 1 billion parameters up to DeepSeek's hundreds of billions of parameters. We are going to have to find a model small enough to fit in our Raspberry Pi's RAM. More about that model later. For this project, I will be using a Raspberry Pi 3 Model B, a bit of an older model, which is going to make this a little bit more challenging. It has a 1.2 GHz quad-core ARM processor, which is going to be used to do the calculations for the LLM token generation and processing. But the bigger bottleneck is going to be the RAM, which is only 1 GB in this model. So we will need to find a model that fits inside it, with some spare space for prompt contexts and so on. If you have a newer Raspberry Pi, like the Model 4 or 5, it can have up to 8 GB of RAM, allowing you to load much bigger model than in this video. But remember, if you load, let's say, a 7 GB large language model, the CPU is probably going to be the next bottleneck, so the token generation can be quite slow. Experiment with different size models to find one that is suitable for your needs and requirements. Now, since we know roughly the specs of our machine, let's try to find a right model for it. We want something smaller than 1 GB to fit into our RAM, and our choices are quite limited at this scale. But looking around on Hugging Face, I think a suitable model for us is the Llama 3.2 1B Instruct from Meta. At full precision, the model size is around 2.5 GB, so we need something smaller. Now, let me introduce you to the concept of quantization. I have to be real with you, I do not quite understand how it works fully, but roughly speaking, it's about decreasing the precision of the model weights. For example, from a 16-bit floating point variables to 8-bit variables, meaning you only need half the space to store roughly the same information. Quantization is super popular in the local LLM community, and I personally use it all the time, almost never using the full 16-bit precision. So, looking at different quantizations for our selected model, we can see that the space requirements are now much closer than we want. Great! I had a small gotcha here. I had downloaded this Q4 quantization of the model because it mentioned that it was optimized for ARM inference. But I could not make it run on any software, so I instead went with this quantization here. It's a bit bigger, but that means it has better precision and thus better responses, at least in theory. Alright, let's get to actually trying whether the software works on this ARM board or not. First up, I tried Llama file. which is a single executable that runs on the inferior server and all of that. It can even include a model in the same file, so you just need to download a single file and can be serving an LLM in no time. That's quite handy. They advertise that they combine both AMD 64 and ARM 64 to a single binary, and executable includes a shell script that chooses the correct one to run. This functionality actually kind of worked for me. I downloaded executable, pointed it to my model, and it ran perfectly fine. I opened my web browser and was greeted by the integrated chat UI. Great, I thought to myself. Then I put in a question as a prompt, and illegal instruction appeared. I tried this a few times and kept getting the same error every time. I think it has something to do with Raspberry Pi's older ARM model, which probably doesn't support all the latest ARM instructions. So, using llama file is out, but luckily we have other options as well. Next, I tried Cobalt CPP, which is a fork of llama CPP with some additional functionality, such as image diffusion support and a more advanced UI. I tried downloading their Linux release and running it, but it wouldn't run at all. I'm guessing it's for x86 only. No big deal, I can just build the project myself, suited for my ARM Raspberry Pi. I downloaded the Git repository, installed some build dependencies, and got to building. It took ages to build, and as you can probably guess, in the end, the build process just kept crashing. I tried it several times, but it just kept crashing when building the image generation code. Maybe the related code is too complex or the code base is too large for Raspberry Pi to handle, so I abandoned Cobalt CPP too. After failing to run with these two projects, I decided I needed to go simpler. I downloaded the original Llama CPP project, from which all of these other programs are forks of. I checked their releases and they said they had releases for Ubuntu ARM 64. I was excited to try it, but alas, it also wouldn't run. Darn. My last idea was to try and build it myself, even though I had pretty bad experience with building Cobalt CPP. I downloaded the Git repository and got to building, since the dependencies are mostly the same as in Cobalt CPP. It took absolutely ages, like way over an hour to build, but to my surprise, it actually built. It spit out a llama server executable that I could use to serve my model. I pointed it to my model, started the server, and lo and behold, it gave me an URL to view the web UI. I opened my browser and was greeted by a simple chat UI. I anxiously tried asking it something simple. It took several seconds as it thought about it, but finally it answered me. Success, finally, I thought to myself. I had got an LLM to build and work on a Raspberry Pi 3. Now let's finally look at the results. Here is me asking it for the capital of France and... boy, it's sure taking a long time to respond. But eventually it starts outputting an answer. It's not really quick, but it's an answer nonetheless. The reason why it's so slow to initially give a response is due to prompt processing. Looking at the logs, we can see that it takes around 1.5 seconds to process a token. A singular token is usually a bit smaller than an English word. So no wonder it takes such a long time to process if we include the initial system prompt as well. It usually takes around 20 seconds to process the prompt, but this can be quite a bit lower in future prompts due to prompt caching functionality. I then decided to ask it a bit more challenging question and asked it for the tallest building in North America. I'll speed up its answering process here, but it took over a minute to give me a complete answer. Interestingly, everything in the reply seems fine and correct, but there are a few issues. Yes, One World Trade Center is the tallest building in North America, but the issue comes with its exact height. The foot count is correct, but the meter conversion is wrong. It should be 541 meters. Also, the floor count seems to be wrong, as Wikipedia claims it has only 94 floors. It calls the building one of the most iconic and recognizable, which is highly subjective, and quite frankly, I don't agree with it. To me, One World Trade Center looks like any other skyscraper. Sure, the shape is quite different, being built out of triangles, but I don't really think it's that recognizable. Anyway, other than that and the few technical mistakes, the response is satisfactory. Finally, I wanted to try its creative writing skills and asked it to write a short story about a dog. I got impatient after a couple of minutes as the output was so slow, but this is the start of the story. It came up. The story is not bad, but it feels quite jumpy and fast. Also, the pace seems a bit off. In the story, Sarah calls out for Max first, and then turns around to see him not there, which feels like the wrong order of things to happen. But still, a satisfactory answer from such a vague prompt, I think. In conclusion, yes, you can run large language models on a Raspberry Pi, but be prepared to compromise heavily on the model complexity, only using models in 1 to 4 billion parameter range. Also be prepared to wait, as processing and generating the prompts on a Raspberry Pi's ARM processor is quite a daunting task for it. You probably can't reach so-called readable pace, around 5 to 10 tokens per second, but you can probably achieve something a bit slower, like 2 to 4 tokens per second. Also, since Llama CPP provides an OpenAI compatible server, you can use the model in tons of different applications, like Home Assistant or command line coding tools, or any chat application really. Thanks for watching the video, and on to the next one.